In example 4, our piecewise defined function is k of x is equal to 2x plus 5 if x is between -3 and 1, including -3, and then it's -3 if x is actually equal to 1, and then it's equal to 2 if x is bigger than 1. All right, so we're going to do the same four things with this piecewise defined function. Okay, we're going to start by graphing it. This is the first time we've had 3 rules. Okay, all the other ones that we've done have had 2 rules. This one has 3 rules. Doesn't matter, we're going to do it the same way. You'll just have to make a third table. Okay, all right, so here we go. I'm going to color code this. I'm going to put rule 1 in green, and then I'm going to put rule 2 in red. And then lastly, I'll put rule 3 in blue. Okay, so we are going to start with rule number 1. Okay, so we're going to have to make a table of values. So I will come over here. The first thing to notice, okay, before we make the table, let's talk about the rule change. Okay, when you look at these conditions, the numbers that you see here, you see 2 different numbers, okay, not just one, and that's because there's 3 different rules, so there's actually going to be 2 numbers involved now. I see something, going on at -3, and I see something going on at 1. So actually, before I make the first table here, I'm going to go ahead and put some vertical lines out so I know something's going on at x equals -3. Okay, these lines are going to be gray since I'm coloring rule 1 in green. Okay, and then there's also something going on at +1. So at x equals +1, something's going to be going on there. Okay, again, these vertical lines are not part of the graph itself. These are just reminders that, we're probably going to we might have something going on over here, and then we have something going on in between the 2 vertical lines, and then there's something going on over here. Okay, we have to abide by the vertical line test. So these vertical lines are just reminders that we cannot cross these dotted lines. Okay, all right, so let's get started with rule number 1. And again, I will put that in green. Okay, so we're going to make a table of values. So again, we will be in charge of x, and then we're going to take each x value and we're going to plug it into our rule. The rule here is 2x plus 5. Okay, so here we go. We're going to pick our x values. The y value you're going to get by doing 2 times x plus 5. Now, when we look at the rule here, okay, we have to look at the if condition. Okay, so let me go ahead and erase these 2 that we don't need. So we're looking at what's in yellow here. This rule, 2 times x plus 5, is valid only for x values between -3 and 1. Okay, so it's a little bit different of a condition that we've seen previously because we don't have something like x is less than 1 or x is greater than or equal to 1. We're the x values are stuck between 2 numbers. So what we're going to do here, again, this rule is only valid between these 2 x values. So I am the first x value I'm going to put on the table is -3. And the last one I'm going to put on the table is 1, okay? Because this particular rule is valid in between these x values, okay? So it's kind of like the idea of like when you make your table, the first thing you need to put in the table is where the rule changes. Well, this rule is kind of starting at -3 and it's stopping at 1, those particular x values. So those are the rules we're going to throw in, or those are the x values we're going to throw in the table. Okay, so to make it accurate, I'm going to fill it in between. So we'll look at x equals -2, -1, and then 0, and then 1. Okay, that will define rule 1 for us. Okay, so I'm going to take each of these x values and plug them into the function. So if x is -3, we're going to get y is equal to 2 times -3 plus 5. That's going to be -6 plus 5, which is -1. Okay, so this is going to be looking at the point, and let me see, where can I write this? It'll be the point if x is -3, y is -1. And then I'm going to move on to x equals -2, plug that guy in. So we're going to get 2 times -2 plus 5. That's going to give us -4 plus 5, which is +1. So if x is -2, y is +1. Moving on to x equals -1, we're going to get that the y value is 2 times -1 plus 5. That's -2 plus 5, and that's going to be 3. So if x is -1, y is going to be +3. And then if x is 0, we're going to get y is 2 times 0 plus 5. That's 5. So our graph will go through the point 0, 5. And then lastly, we will take a look at what happens if x is 1. That will give us a y value of 2 times 1 plus 5. That's 2 plus 5, which is 7. So the last point here will be 1, 7. Okay, so we've made our table of values over the x values between -3 and 1. And before we can plot these points, we need to determine what's going on where the rule changes occur. Okay, we have to check. There's 2 rule changes here. Okay, this rule exists between -3 and +1, those x values. So we actually have to take a look at x equals -3 and also x equals 1. Okay, all the x values in between will be closed circles, but we need to see if the point at x equals -3 is going to be open or closed, and same with x equals 1. Okay, will the circle there be open or closed? Okay, so let's first start with x equals -3. If you go back to the conditions here, it says x has to be between -3 and 1, but we need to focus on this inequality symbol. It says -3 is less than or equal to x. So x can actually equal -3 here, so it's legal to plug in -3. Okay, so the corresponding point on the graph, -3, -1, this is going to be a closed circle. Okay, because you can actually plug -3 in for x into this rule. It's valid. Okay, we need to check the same thing for +1. Okay, the other place where the rule changes here. Okay, so if we look at the condition, okay, because this is talking about the point where x equals 1, so the point 1, 7, will it be open or closed? Well, you have to go up here, and when you look at your condition here, it says x has to be strictly less than 1. It does not read x is less than or equal to 1. Okay, so because x has to be strictly less than 1, okay, x is not allowed to be 1, so that means it's not legal to plug in 1 itself. So 1, 7 is going to be an open circle. Okay, so we're going to plot these points. Okay, 2x plus 5, y equals 2x plus 5, that is a line, y equals mx plus b. So these points should fall along a line. Okay, we will start with -3, -1. Okay, and actually I've got this vertical line in the wrong place. I drew it through x equals -5. That's my bad. Okay, so let me correct it before we go on. Okay, so it should be right here. This is x equals -3, so sorry about that. Okay, the line should be right here. All right, so now let's start plotting points. Okay, so -3, -1. Okay, that's going to be a closed circle right here. Okay, and then the next point will be -2, 1. That's going to be closed. Remember, all points are closed circles unless the only possible place to have an open circle is where the rule changes. Okay. All right, the next point is going to be -1, +3. That's right here, closed circle at 0, 5. And then lastly, 1, 7, we said is an open circle. Okay, so here we go. And you can see this particular line is falling in between the 2 vertical dashed gray lines. Okay, and they are falling into a line pattern here. Okay, so we're going to go ahead and connect the dots. Okay, this line exists in between these 2 gray vertical lines. Okay, can't cross the dotted lines or you may violate the vertical line test. Okay, so this is what rule 1 looks like, completely graphed out. Okay, so let's take a look at rule number 2 now. Okay, I'm going to put that in red. Rule number 2, if you look at the condition here, rule number 2 talks about specifically what is going on at x equals 1. Okay, so basically what rule number 2 is telling you is that if x is 1, then k of x, which is y equals -3. Okay, so rule number 2 is just a point. Okay, so rule 2 is just a point. Okay, because it's only telling you what happens exactly when x is 1. Okay, so if x is 1, y is -3, that's going to be this point right here. You do want to include it. Okay, so you're just going to put this red dot as a closed circle right here. Okay, that's it for rule 2. It's just a dot. Okay, so now we will move on to rule number 3. Okay, so rule number 3, the condition is your x values have to be bigger than 1. Okay, so basically that's where this rule is going to exist, over x values bigger than 1. Okay, so that's going to be to the right of this second vertical line. Okay, you'll have a graph over here somewhere. The funny thing about this particular rule is that it's k of x is equal to 2. There's no x. So you might be confused about that. So let's just see what happens if we build our table. Okay, so again, I'm going to build a table here. And I'll be putting this rule in blue. Okay, we are again in charge of x. And we get to pick the y values. Okay, now remember, k of x is y equals 2 here. That's the rule. Okay, now let's talk about how we can choose our x values, how we should choose our x values. First thing that needs to go in the table is the x value where the rule changes. That's going to be 1. Okay, and then you need to pick x values bigger than 1. Okay, so I'll pick 2, 3, and 4. That should be enough to see what's going on. Okay. All right, so for each of these x values, we're going to plug into the function. Okay, so if x is 1, when you plug in, there's no x to plug in to. Okay, the result is just going to be 2. Okay, if x is 2, again, there's no x. It's not 2x, that's the function, it's just 2. So if x is 2, the output's going to be 2. Basically, if your x values are bigger than 1, y is always 2. Okay, so if the x value is 3, guess what the output is? You got it, 2. If x is 4, the output is again 2. Okay, and so on. Okay, so you end up with these ordered pairs. Okay, so we need to plot them. Okay, but before we do that, we have to check what's going on where the rule changes. Okay, where x equals 1, the first thing in the table here. Okay, was it actually legal to plug in 1? Okay, and the answer is, if you look at the condition, rule 3 only holds if your x values are strictly bigger than 1. You don't have bigger than or equal to. So as a result, it's not actually legal to plug in 1 for x in this rule, so that makes the point 1, 2 an open circle. Everything else will be closed. Okay, so in blue, I will go and plot 1, 2 as an open circle. That's right here. Okay, and then everything else will be closed. So 2, 2, 3, 2, 4, 2, and so on. You know, if you plugged in 5, you were going to get 2 as the result. If you plugged in 6, you were going to get 2 as the result, and so on. Okay, so you can see that a horizontal line is being formed here. Okay, we can go ahead and connect the dots to the right of this second gray vertical line. Notice this rule holds for all x values bigger than 1. So when you connect the dots, you have to put an arrow going this way, because you have to, you know, this is going to hold, like I said, for all x values bigger than 1. Okay, this is the complete graph. You see rule 1 in green, rule 2, the dot in red, and then rule 3 in blue. Okay, notice there is no graph over here whatsoever. Okay, there's nothing over here. It's just blank. And that is because there is no condition, there's no if condition for x values less than -3. Okay, so it's just going to be blank. Okay, the graph is complete. Okay, all right, so now that we've got our picture, let's go and do some evaluation here. Okay, again, this is where you're plugging in an x value and you're getting a y value as the result. Okay, notice the graph does pass the vertical line test. You know, if you can imagine drawing vertical lines in different places, it's only going to hit the graph in one spot. The only tricky spot might be at x equals +1, But, you know, if you're looking at that second gray dotted line here, you've got the option of the green open circle, the blue open circle, and the red closed circle. A vertical line is only going to intersect the graph there in the red closed circle because that's the only point that counts there. Okay, so we do pass the vertical line test. So you have to keep the same idea when you're evaluating the function. This is a function. Every input has to have a single output. Okay, you can either do this graphically or you can plug into a particular rule. All right, let's start with k of -4. Okay, so for k of -4, your x value here is going to be -4. Okay, so let's go see what happens here. Okay, here is an x value of -4. Okay, and if you notice, if you go up to the graph, okay, or you go below to find the spot corresponding point on the graph, there is no corresponding point on the graph. Okay, so what you're going to write here is undefined. Okay, there is no graph. If your x value is -4, there's no output. Okay, the graph is not defined there. Okay, so that's all you need to write. You can write none, undefined, anything along that line. There is just no y value there. Okay, all right, so let me go ahead and erase that. Okay, and then we're going to talk about k of -3. Okay, when you move on to k of -3, so here your x value is going to be -3. Okay, so you're basically saying, okay, if my x value is -3, what's the y value? Okay, so if you go up to the graph, here's where, if you look where my cursor is, here's where x is -3. And if you find the corresponding point on the graph, this point is -3, -1. So what you can see from the picture, if x is -3, y is -1. So that is your answer. Okay, you could have done this from the formula. Okay, if you go up to the rules, you have to figure out if x equals -3 falls into rule 1, rule 2, or rule 3. And x equals -3 falls into rule 1. Okay, it fits the bill of x's between -3 and 1, including -3. Okay, so you could have used rule 1 here. Okay, rule 1 is 2x plus 5. Okay, so you would just plug in the x value of -3. And that would give you -6 plus 5, which is the -1. Okay. All right, moving on. K of 0 is next. So here, x is 0. Okay. So if we go to our graph, we're going to find where x equals 0. Okay, if you look at my cursor, here's where x equals 0. We're going to go up to the point on the curve. The point on the curve here is 0, 5. Okay, so that tells us that if x is 0, y is 5. So the answer here is going to be 5. All right. If we chose to use a rule, okay, again, you've got to figure out, does x equal 0 fit rule 1, rule 2, or rule 3? Well, it's going to fit rule 1 because x equals 0, that's a number between -3 and 1. Okay, so you would use rule 1. Okay, so you would do rule 1, that's 2x plus 5, plug in x equals 0. That's going to give you 0 plus 5, which is 5. Okay. Moving on to k of 1. Here, x is 1. Okay. So if you look at the graph where x is equal to 1, that's right here. Okay. If you go up to the graph, you have to choose between the green open circle, the blue open circle, and the red closed circle. Okay, we know the open circles don't count, they're excluded from the graph, so you have to go with the closed circle, which has coordinates 1, -3. Okay, so that tells us that if x is -1, the y value is -3. Okay, so you're just going to write down -3 is your answer. If you go to the formula, okay, remember x is exactly 1, and so for x to be exactly 1, that condition is rule 2. Okay, so rule 2 tells you that if x is 1, the y value is -3. Okay, last evaluation here, we're doing k of 6. So x is 6. Okay, if we go to our formula, or sorry, to our graph, we find where x is 6. That's right here. If we go up to the point on the graph, this is 6, 2. Okay, so if x is 6, the y value is 2. So the answer here is going to be 2. Okay, if you relied upon the formula, you're dealing with an x value of 6, okay, that falls into rule number 3 because it covers x values bigger than 1. And so we know that any x value bigger than 1, including 6, is going to have an output of y equals 2. So the answer is 2. Okay, so I'll even write that here. Here you would use rule 3, and you would just get a y value of 2. Okay. All right, let's move on to domain and range. Okay, it might be a bit tricky. Again, our graph is not connected. Okay, so we're just going to do the number lines here. Okay, let's start with the domain. We need to figure out what x values this graph covers. Okay, so I'm going to draw a number line that is going to represent all the x values. Okay, all right, so let's talk about rule number 1. Rule number 1, it exists for x values between -3 and +1. Okay, so basically, if you look at the endpoints here, x can be, or -3 is less than or equal to x, so x can actually equal -3, so I'm going to put a closed circle there. As far as 1 goes, x has to be strictly less than 1, so we don't want to, rule 1 does not cover what happens at x equals 1, so I'm going to put an open circle there. But rule 1 applies for all x values in between. Okay, then rule 2 comes along, and it covers exactly x equals 1. So I'm going to color x equals 1 in. And then rule 3 comes along, and it covers x values strictly bigger than 1. Okay, forever. So if you walk around this number line, if you walk along it from left to right, you can write this in interval notation. You can see that the domain here is going to be all x values -3 and bigger. Okay, so the first number we hit on the number line is going to be -3. Okay, we're going to include it because it's a closed circle. And then if you're walking along this interval, you're going to walk off to +infinity. Okay, so that should be reflected in the graph. Okay, the leftmost point on this graph is this green closed dot, which has coordinates -3, -1. Its x value is -3. Okay, and then if we go along, okay, we jump off the green part, okay, to the red part. That covers x equals 1, so x equals 1 is covered. And then after that, we just ride the blue part off to x equals infinity. Okay. All right, so that's your domain. The graph covers all x values -3 and bigger. Okay, now we're going to look at range, which is the y values. That's always the trickiest part. Okay, so here we go. We're going to make another number line. Okay, it's just difficult to kind of look at from the graph. I mean, you can totally look at the graph if you prefer to do it that way, but it's a little confusing when the graph is not connected. Okay, all right, so let's talk range here. This is going to represent our y values. Okay, so let's talk about rule number 1, which I will put in green. If we look at the green segment here, okay, the low point on the green segment is the point -3, -1. That is a y value of -1. Okay, that is a closed circle, so we're going to include -1 in the range. Okay, and then we'll go up to the high point. Okay, the high point is right here, the open circle. It has coordinates 1, 7. Okay, so we're going to write down the y value there. It is 7. Okay, it is an open circle, so we're not going to include it there. Okay, but the green segment includes all the y values in between. Okay, so in between -1 and +7. Okay, then if you look at rule 2, that's the red dot. Okay, it's all by its lonesome, and it only has one y value, which is -3. Okay, so at -3, I'm going to put a red closed circle because that y value is covered by rule 2. Okay, and then we will look at rule number 3, and I'll color that in blue. Rule number 3 only has one y value. If you look at the table especially, you see that the y value is always 2. Okay, that's the only output there. Okay, so here's where 2 would be on the number line, maybe here. And then the third rule, that's its only output. Okay, so you can see what's going on here. Okay, what y values are shaded on the number line? Well, y equals -3, and then you take a break, and then everything between -1 and 7. Okay, so let's write this in interval notation. Okay, so we've got the -3 by itself. Okay, I'll come back and talk about that. Then we take a break and we've got every number between -1 and 7. Okay, so the -1 and 7 is going to be an interval notation because it's not just the endpoints, it's every number in between decimals and fractions. If you notice, there is a closed circle at -1 and an open circle at 7. So we will put a bracket on -1, a parentheses on 7. Okay, you can't put -3 in interval notation because it's just one point. It's all by itself. So what you do, because it is a valid output, you can put the little braces on it. We're just considering that one point together with this other interval. Okay, this is a crazy range. It's pretty hard. Okay, but if you can see it, then you really know what you're doing. Okay, this is a tough problem. Okay, this is the range. All right, last question. Is K continuous on its domain? Okay, can you draw this graph without picking up your pencil? Okay, and the answer is obviously no. Okay, if you the graph starts at -3, -1. If you start traveling from left to right, once you get to 1, 7, you have to pick up your pencil to go down to the red dot. And then once you make the red dot, you have to pick up your pencil to jump to the blue part, and then you're good. Okay, so basically, obviously, it is not connected. Okay, so we're going to say it is not continuous on its domain. Okay, where is the discontinuity? Okay, and you got to kind of be careful here. Where is it continuous on its domain? So where is the discontinuity on its domain? Okay, you might be wondering, well, do I consider x equals -3 a discontinuity? And the answer is no, because that's where your graph starts. Okay, so once your graph has started, where do you have to pick up your pencil? Okay, well, I have to pick up my pencil at the second gray dotted line. Okay, and that's x equals 1. Okay, so the discontinuity here is going to be at x equals 1. That's where you pick up your pencil. Okay, that is it for this graph. Okay, this was a tough problem. Okay, not only did we have 3 rules, but it was very choppy. Okay, so the domain and range here may be difficult. Okay, so review it and let me know if you have any questions.